Hi, and welcome back to my channel. This week's problem is about trying to find the area of the green triangle, as you can see in the diagram here. Now, this shape is made up of lots of different shapes, but inside of that overall shape is three equilateral triangles. I'm going to show you where those are in a second, because they're not the easiest to spot. Now, we've also got labelled on the diagram the areas of some shapes. So on the leftmost triangle here, that's got an area of 13. On the blue quadrilateral, that's got an area of 5. And the pink rightmost triangle has got an area of 11. Now, like I say, it's all well and good me telling you there are three equilateral triangles here, but without me telling you exactly which ones are equilateral, it can be quite confusing, especially because some are very close to other triangles, such as the one on the right-hand side there. So the first triangle that's an equilateral triangle is this triangle here, like an orangey pink. Let me know what color that is. I'm not really sure down in the comments, but that's an equilateral triangle there. We've also got on the right-hand side, highlighted or outlined in pink, this equilateral triangle. So it includes that small white section there as well. Now, we've got our third equilateral triangle, which is highlighted in red here. That's the largest one. And that incorporates that blue quadrilateral at the top, the green triangle at the bottom, and there's two white sections there as well. Now, to make it easier for me to explain my solution, and also if you want to share your solution, please do, down in the comments below, I've labelled each of the vertices here. Now, as well as that, I've labelled each of these white sections, so that leftmost one is X and the right one is Y, just so it's easier to refer to later on. And when I say those sections, I mean the area of those sections, just to be clear. Now, if you want to have a go at this problem yourself, pause the video now. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that we're going to do is make the diagram smaller, because then it's easier to get everything on the screen. And then from there, I'm going to look at this green triangle. And actually, by Pythagoras, I know that AH squared plus GH squared is equal to AG squared. So the sum of the squares of the two smaller sides of a right-angled triangle are equal to the square of the hypotenuse. Okay, right, so that's pretty straightforward. Now, from there, I've got equilateral triangles, and I've got the areas of parts of those equilateral triangles. So I'm going to think about the area of a triangle, and I'm going to think about it in terms of a half AB sine C here, because that's easier for working out the area of an equilateral triangle when we don't have a perpendicular height. And actually, what's interesting with an equilateral triangle is that we know the angle in each one of the corners. It's going to be 60. Okay, so it's a half AB sine 60 actually for the area of an equilateral triangle. And on top of that, A and B are the same thing. So we could just write that as A squared. Now, from there, we've got a half A squared sine 60. Well, sine 60 is root 3 over 2. And after that, I can do root 3 over 2 times a half, which is root 3 over 4, A squared. Now, A is referring to one of the sides of the equilateral triangle, and it doesn't matter which one because they're all the same. So I'm timesing two of the sides together, a side squared, if you like, and then I'm timesing it by root 3 over 4, and that will find me the area of an equilateral triangle. So looking at the equation I made with Pythagoras earlier, I've already got a side length squared. So if I times everything in that equation by root 3 over 4, then really what I've got here is I've got the area of three equilateral triangles. And it just so happens that each of these sides correspond to the three different equilateral triangles involved in my diagram. So actually, I could write this as triangle ABH, the area of triangle ABH, plus the area of triangle FGH is equal to triangle ABH, or the area of that triangle. And then from there, I can write the areas of each of those triangles in terms of numbers and X's and Y's and a question mark. So let's do that. So ABH, well, that is going to be 13 plus X. And then we have got GFH, which is 11 plus Y. And then we've got our outlined red triangle ADG, which is 5, plus the X, plus the Y, plus that question mark. So what I can now do is I can start simplifying this and work out what the question mark is, what the area of that green triangle is. So 13 plus 11 is 24. I'm going to take X away from both sides here. I'm going to take Y away now from both sides here. And then I'm finally going to take 5 away from both sides, and we get the answer, which is 19 units squared. Isn't that pretty cool? I think, at least. Now, if you manage to get the same solution as this, or sorry, the same answer, but the same solution, or a different solution, maybe better, put that down in the comments below, share with other people so they can see if they were trying a different method, if they went wrong, actually what was the right way to follow through with that method. Now, all that's left to say is thank you so much for watching, especially if you're a repeat viewer. If you come back to the channel, I really appreciate you watching all the videos. And if you're not already, please consider subscribing to the channel because it really helps the channel and helps me out as well. Thank you so much for watching. I will see you next Monday at 5 PM for another problem-solving video. Until then, bye-bye.